Okay, let's look at 4.1.2. So building on the previous lesson, lesson 4.1.1, you sketch graphs of polynomial functions based on the factored forms. In this lesson, we're going to reverse our thinking and we're going to write equations of polynomial functions from their graphs. So let's just go through these first four here. So if you're looking at A and you're looking at this graph, what we're doing here is we're using what we used yesterday. So if we look at this, we should know that it's at least a third degree or a cubic function, right? So two curves, cubic function, 3 zeros, right? So we have zeros at x equals -3. We have a 0 at x equals 0, and we have a 0 at x equals 2. So if we're writing this equation, that would be y equals x plus 3, x, and x minus 2. So that's factored form based on our zeros. Okay, if we look at B, so doing the same thing here, third degree, right? We should notice, though, that on B, not only is it a cubic, but it's also negative, right? Why? Because it's in behaviors up then down, right? So two curves, right? Our zeros are at x equals -2 and x equals 1. But we should notice that -2 is a double root, okay? So from the previous lesson, we should notice that right there is a double root, okay? So then what we can do when we're writing this equation, y equals, change back to my black here, y equals, okay, x plus 2 squared, double root, and x minus 1. But remember, it's negative, so we have to put a negative in the front. Okay? Now, here's the thing. Okay? So when graphing these, if you notice, there are points here. So if you look at A, right, there's points on this graph. So let's say the point 1, -4. So we need to test that point to see if this equation works. So let's go back to 1, and let's test the point 1, -4. Okay, so y is -4, x is 1. We're going to see if that works and actually gets us that point. So 4 times 1 times -1, we actually get -4, which is what we were trying to get. So this equation works. This is great. Okay, let's look at this one now. So on 2, let's try the point, how about 0, 8? Okay, so let's try the point 0, 8. So y is 8. 0 plus 2 squared, 0 minus 1. So this is 2 squared, -1. 2 squared is 4. 4 times -1, and we got a negative in front. So this is actually a positive 4. We need it to be 8. So on every one of these equations, there's an a value in the front. So there's an a that goes in front. This one just happened to be 1, so it worked. It's understood 1. Right? This one, in our case, needs to be 2. So 2 times 4 gets us 8. So if we write this equation, it ought to be y equals -2 x plus 2 squared and x minus 1. So that we're getting the exact values of those equations. Okay, so now let's do the same thing for C. So 4th degree, right? It's negative because it's down, down, right? So again, even degree, same in behavior, but we have 3 curves. So it has to at least be a 4th. Our zeros are at x equals -2 and x equals 1. Both are double roots, Okay, so we have y equals negative a, that whatever that a value is, x plus 2 squared, x minus 1 squared. Now, we need a test point. How about 0, negative 3? So let's test 0, negative 3. So negative 3 is our y. 0 plus 2 squared, 0 minus 1 squared. So 2 squared is 4, 1 squared is 1. So I have 4 times negative a equals a negative 3. Again, we're just solving now. So divide by 4, and I get negative 3/4 equals negative a. So the a value is actually 3/4, right? The negatives go away. And I can come back up here, and I can now say, oh, okay, that a value is 3/4 to get me that equation. Okay? Same thing for D. Let's look at D. Okay, let's count our curves. 1, 2, 3, 4. So this is 5th degree. 5th degree, right? It is negative because it's up, down. So it's negative. Okay, and our zeros are at x equals negative 3, 0, and 2. But 0 is a triple root. See that? Now, it could be more than that, right? We learned yesterday that that's just flat. We can't quite tell if that's more than that. We know it has to be odd, so it could be a triple root or a 5th root, right? Or so forth or so on, but it can't be anything else, right? So let's do this now. So let's look at our equation. Y equals negative a x plus 3. We're going to say x cubed on the triple root, and then x minus 2 on the other root. Okay, now let's find a test point. They give us one. It's negative 1, negative 6. So let's test that point. All right, so negative 6 equals y, and we're going to find that a value. Negative 1 plus 3, negative 1 cubed, negative 1 minus 2. Okay, so we have negative 6 equals negative a. We have 2, we have negative 1, we have negative 3. So this is going to be a positive 6. So again, if we solve, we get negative 1 equals negative a, or a equals 1. So we can come back up here, and we know that that a is just a 1. Okay? So now, on 23, it says graph the following polynomial function based off, it bounces off the x-axis at 2, 0. So that's a double root, right? So we have a double root. This is 23, right? We have a double root at negative 2. Okay, it crosses at 5, so we have another root at 5, and we have a point that it passes through. So we have a cubic function, right? So we have y equals a x plus 2 squared, double root, and x minus 5. Okay. So we need to solve for that a value. So our test point is 1, negative 12. So we do negative 12 equals a, 1 plus 2 squared, and 1 minus 5. Okay, so 3 squared and negative 4. That's negative 36. We divide that, and a is 1/3. So we get an a value here of 1/3. Okay, so we have our graph. We have our equation, right? It says B, Gilbert came up with the equation y equals 27, x squared to the 4th, and x minus 5. Does his equation fit all of the given criteria? Well, let's see. If you plug in 1, they'll get 3 to the 4th. That's 81. 81 divided by 27 is 3. and then 1 minus 5 is -4. 3 and -4 is -12. So it does work, right? It bounces off. This crosses. This bounces off at 2. It's just a 4th degree, right? Or a 4th root there. So yeah, it does work. So what if it is also known that the graph passes through -1, 2? So now we could test that with ours, right? So if we test again, -1, 2, and we plug this in, right? 2 equals 1/3. -1 is going to get us 1 squared, and -6, right? So that's going to get us 2. So ours works, okay? Gilbert's does not work in this situation. So when you plug in -1, 2, his does not work. So what information about the graph of the polynomial function is necessary to determine exactly one correct solution? Well, a couple of things. You either need 2 test points, or you need to know the degree. Right? You got to know one of these 2 things to be able to get exactly one equation. Okay? All right, so look at 24. The graph of the polynomial function passes through the points -160 and has 3 x-intercepts. How many different equations are possible? Well, infinitely many, right? Like, all we know is that these are x-intercepts. We don't know that they bounce off. We don't know that they're double, triple roots, right? So we could get a ton of things, right? So then it says list additional criteria, either another test point or the degree, right? So it goes back to that. So if you look at 25, Ramon needs to write the equation of the 3rd degree polynomial. So we know the degree. We have the 3 intercepts, and then we have a y-intercept. And she comes up with this equation. Okay, and why is that not correct? Okay, so what has happened is she's taken a y-intercept and just added it to the end. Well, what happens though is when you actually multiply this out, which is where that y-intercept comes from, is standard form, not factored form. But when you multiply this out, you don't get a 6 of a y-intercept. And so the way to test this would obviously be just plug in 0, 6. So this is number 25. If we plug in 0, 6, 6 equals 0 minus 3, 0 minus 4, 0 minus 5, plus 6. You can see we're not going to get 6, right? So -4, or -3, -4, -5. So this is going to be a -60 plus 6, and we're going to get a -54, not 6, right? Not this 6. So what she did is she thought she could just add that y-intercept on the end. That only works when it's in standard form. It doesn't work in factored form. So in order to do that, she just needs to use it as her test point, that 0, 6, and do it as we've been doing it, and then just change that a value at the front of our factored form equation. Okay, and then so just for your practice, what I would do now is just pause the video, and I want you to write a 3rd degree polynomial for the graph intended. So that would be a 3rd degree polynomial, test point 0, 16. You write that out, and then come back, press play, and then check it. And there you go. And this is lesson 4.1.2.